Very warm good morning to one and all. This is Maria Pushpam, and for today's class, we are going to see hardness. The chemical parameters, we have seen 4 parameters, nothing but pH, acidity, alkalinity, and TDS. And for today's class, we are going to see hardness, especially temporary hardness, permanent hardness, total hardness, calcium hardness, magnesium hardness, also chloride and fluoride content in water. And the remaining chemical parameters we can see in the next class. So now I'll start with hardness. All of you know what hardness is. Yes? Hardness is nothing but it's a property of not producing lather with soap. Okay? If you take water, we say soft water as well as hard water. If a water is readily giving lather with soap, it is said to be soft water. If does not produce lather with soap, we call the water as a hard water. Is it okay? நம்ம எல்லாருக்குமே தெரியும். You have noticed if you go beyond Nagarkoil, that is if you go to Tirunelveli or beyond Tirunelveli, the water is said to be hard water because it contains large amount of salt in it. So it won't produce any lather with soap easily. If you take our district, we are blessed with good water. It will give a very, it will foam very easily with soap. So it is said to be a soft water. Is it okay? So water which does not produce lather with soap is called as hard water, and the property is called as hardness. There are two types of hardness. One is said to be temporary hardness, another one is said to be permanent hardness. Now we can see what is said to be temporary hardness. So what do you mean by temporary hardness is if it is due to the presence of bicarbonates of calcium and magnesium in water, we call it as temporary hardness. So temporary hardness, it is because of the presence of bicarbonates of calcium and magnesium ion in water. We call it as temporary hardness. And this temporary hardness can also be called as carbonate hardness because it is mainly due to the presence of bicarbonate ions. Okay, and why we use the word temporary hardness here is this hardness can be easily removed just by boiling the water. நீ தண்ணியை கொதிக்க வச்சேன்னா போதும், உனக்கு temporary hardness வந்து போயிடும். சரியாமா? So this hardness we call it as temporary hardness. அது பெர்மனண்டாக இருக்காது. சரியா? So next hardness is said to be permanent hardness, and this hardness can also be called as non-carbonate hardness. It can also be called as non-carbonate hardness. Okay, it is because of the presence of sulfates and chlorides of calcium and magnesium in water. The sulfate நாலையும் chloride ion, sulfate ion, calcium கூட combine பண்ணி இருந்துச்சுன்னா we call the hardness as permanent hardness. Is otherwise called as non-carbonate hardness. Okay, so because it is of the presence of sulfates and chlorides, it is said to be non-carbonate hardness. Okay, and it's called as permanent hardness. Permanent hardness சொல்றோம்னா, if you boil the water, permanent hardness cannot be removed. Permanent hardness can only be removed by chemical methods. It's clear for you? I'll repeat. So there are two types of hardness. One is said to be temporary hardness, another one is permanent hardness. Temporary hardness is mainly due to bicarbonates of calcium and magnesium. Permanent hardness is due to sulfates and chlorides of calcium and magnesium ion in water. We call it as permanent hardness. Temporary hardness is called as carbonate hardness. Permanent hardness is called as non-carbonate hardness. Okay, and now we are going to see what is it to be total hardness. What do you mean by total hardness? So if we combine both temporary and permanent hardness together, we say the word total hardness. So மொத்த hardness பார்த்தீங்கன்னா என்ன இருக்கும்? டெம்பரரி ஹார்ட்னஸையும் பெர்மனன்ட் ஹார்ட்னஸையும் ஆட் பண்ணிங்கன்னா நமக்கு கிடைக்கிற ஹார்ட்னஸோட பேர் தான் என்னென்னா டோட்டல் ஹார்ட்னஸ். ஓகே, now we'll go with the next one. Next is degree of hardness. So hardness of water is said to be expressed in ppm. It's nothing but parts of calcium carbonate equivalent in million parts of water. So this we say it as a degree of hardness, which is expressed by the unit ppm, parts per million. So hardness of water is expressed as parts of calcium carbonate equivalent in million parts of water. It is expressed as ppm. So if you take hardness, usually we express hardness by the unit ppm. It's nothing but parts per million. That is parts of calcium carbonate equivalent in million parts of water. We call it as degree of hardness. Okay. Now we'll go with the determination. So we can see the determination of total hardness, then permanent hardness, and how to determine temporary hardness. Okay. This is the thing what we have done in our lab. Total hardness we have done in the lab in the first year. You remember, you can recall the thing. We call the thing as complexometric titration. The method is said to be complexometric titration. As I am going to say the thing, you can recall the thing and you can remember. This is a very simple experiment. So determination of total hardness of water is said to, the method is called as complexometric titration method. So what you have to do here is, total hardness of water is determined by titrating water sample against disodium salt of EDTA. EDTA is nothing but ethylene diamine tetraacetic acid. It's called as EDTA. Then you have to take disodium salt of EDTA. So it will dissolve easily in water. So we can, EDTA won't dissolve in water easily. So you have to take disodium salt of EDTA. It will dissolve easily in water. And the indicator we are using for this experiment is called as EBT, which is nothing but areochrome black tea indicator. And the pH has to be maintained at 10. So what's a pH? To maintain the pH is 10, what we do normally is we use a thing called as buffer. We use a buffer here. It's nothing but ammonium chloride, ammonium hydroxide buffer we use here. Okay, I'll go with the experimental portion here. So what you have to do here is, total hardness is determined by titrating water sample against disodium salt of EDTA with areochrome black tea as indicator at pH of 10. Okay, so how to do the experiment is, you take 50 ml of water sample. நமக்கு எந்த water sample வந்து total hardness கண்டுபிடிக்கணுமோ அந்த water sample 50 ml எடுத்துக்கோங்க. What you have to do here is, you have to maintain the pH as 10. Starting from the experiment till the end, the pH has to be in 10. So for that purpose, we are using a buffer. Buffer is nothing but ammoniacal buffer, which is said to be ammonium hydroxide, ammonium chloride mixture. Okay, you add buffer to this, then you add 2 drops of EBT indicator. Now what happens is, the indicator combines with this hardness producing calcium and magnesium ions, and the solution becomes a red color, wine red color. Why it becomes a wine red color is, the indicator combines with the calcium and magnesium ion to form a weak complex. It forms a weak complex. So your as you are adding the indicator, it forms a complex, weak complex. So the color of the solution becomes wine red. Now you have to titrate against EDTA solution. As you titrate the thing, what happens there is, this weak complex will dissociate and this EDTA will form a complex with calcium and magnesium ion, and your indicator is set free. So the color of the solution will become blue, because EBT indicator is having, originally it's having a blue color, dark blue color. Okay, so that color will appear at the end point. So what happens there is, all the calcium and magnesium ion forms a stable complex with EDTA. So at the end point, the color will turn to blue. It's clear? I'll repeat the experiment once again. So what you have to do here is, you take 50 ml of water sample. To the water sample, you add ammonium hydroxide, ammonium chloride buffer, then 2 drops of indicator. You add, as you add the indicator, the color of the solution becomes red color. Why it is becoming red color is, this EBT indicator will form a weak complex with the calcium and magnesium ion present in the water sample. So the solution will become a red color, a wine red color. Okay, ma. So as you titrate the thing against EDTA, what happens there is, EDTA will combine with this calcium and magnesium ion, and EBT will be separated out. So the indicator is coming out, because it's a weak complex, it will break and it will come out. Okay, and now EDTA will form a stable complex with calcium and magnesium ion of water. As all the indicator comes outside, the color completely becomes blue color. So this is the end point of this titration, and from the end point you can calculate what is the hardness present, total hardness present in water. Is it okay? Now we'll go with the next hardness. Next is determination of permanent hardness. So how to determine permanent hardness is you take water sample, then you boil it for half an hour. Why we are boiling is we have to remove temporary hardness. So as you boil the water, I said you initially, as you boil the water for half an hour, what happens here is temporary hardness will be removed. So now the sample contains only permanent hardness. Now you cool the water sample after eliminating temporary hardness, cool it. From that you pipetted 50 ml of water sample. The cold water you take it 50 ml. Then you titrate it against EDTA with the same procedure. You have to add buffer solution. Then you add indicator and titrate against EDTA solution. The end point will be same thing. The end point will be color change from wine red to steel blue. And from the title value, you can calculate the permanent hardness present in the water sample. I'll repeat the same thing once again. So for permanent hardness, what you have to do here is you take the water sample, okay, you take the water sample, heat it for half an hour. So normally we used to take 200 ml or 250 ml water sample we used to take for this estimation of permanent hardness. You take 200 ml water sample, boil it for half an hour, then you cool the sample. As you cool the thing, all the temporary hardness will be removed. Now the sample contains only permanent hardness. Now what you have to do is you add buffer solution, then you take 50 ml of the cold water sample, add buffer solution, then you add the indicator. As you add the indicator, the color will be wine red. Then you titrate against EDTA solution taken in the burette and the end point will be blue color. Is it okay? Same procedure as the previous one. A weak complex will be formed, then a stable, strong complex will be formed. Indicator will be coming outside. So the end point will be blue color, and from the titer value you can find what is the amount of permanent hardness present in water. And we know the formula: total hardness is equal to temporary hardness plus permanent hardness. Using this formula, you can calculate temporary hardness is equal to total hardness minus permanent hardness. And from this you can also calculate what is the temporary hardness present in water. Is it clear? So now we have seen estimation of total hardness, permanent hardness, also we have seen temporary hardness. Next point what you are going to see is how to determine calcium hardness in water, also magnesium hardness in water. So this calcium hardness and magnesium hardness can be separately found out. Okay, we can see one by one. So next thing what you are going to see is calcium hardness of water. So for this purpose, what you are going to do here is the hardness of water is mainly because of the presence of calcium ion. It's called as calcium hardness. So உனக்கு calcium hardness என்னன்னு தெரியும்னா ஒன்றும் இல்லை, வாட்டரில் hardness is due to calcium ion இருந்துச்சுன்னா we call the hardness as calcium hardness. So to find calcium hardness, you have to remove magnesium. As I said you, two cations will be here. One is calcium, another one is magnesium. And anion, if you take, many things are there. What are the things? Bicarbonate will be there, sulfate will be there, also chloride will be there. But we are in need of only calcium and magnesium. We are going to calculate calcium hardness. So what you have to do here is you have to remove magnesium hardness from that. Then only you can calculate what is the amount of calcium hardness. So for that purpose, what you have to do here is you take the water sample. The magnesium ions are precipitated as magnesium hydroxide using 20% potassium hydroxide. நீ என்ன பண்ணணும்னா எந்த சாம்பிளில் calcium hardness கண்டுபிடிக்கணுமோ அந்த சாம்பிள் எடுத்து 20% பொட்டாசியம் ஹைட்ராக்சைடு கூட ட்ரீட் பண்ணிங்கன்னா எல்லா மெக்னீஷியம் அயானும் மெக்னீஷியம் ஹைட்ராக்சைடாக கன்வெர்ட் ஆகி ப்ரெசிபிடேட் ஆயிரும். சரியா? இந்த ப்ரெசிபிடேட்டை நம்ம என்ன பண்ணணும்னா ஃபில்டர் பண்ணணும். ஃபில்டர் பண்ணதுக்கப்புறம் அந்த ஃபில்ட்ரேட்டை எடு. யூ டேக் த filtrate and titrate against Calgon indicator. What's the indicator you have to take here is you have to use Calgon indicator, and the end point is appearance of pale blue color. And from the titer value you can calculate the calcium hardness present in water. I'll repeat. So what do you mean by calcium hardness is nothing but hardness because of calcium ion is called as calcium hardness. Okay, so how to estimate this calcium hardness is, first you take the water sample, you treat the water sample with 20% of potassium hydroxide. What happens here is the magnesium ion present in water will be precipitated as magnesium hydroxide. Okay, so after precipitation is over, what you have to do is you filter the water sample. Filter paniko, filter panit, you take the filtrate and the liquid mattum eduthiru. Okay, you take the filtrate, 50 ml of the filtrate you take, and to the filtrate you add calcium indicator and you titrate against EDTA solution. The end point is appearance of pale blue color, and from the titer value calcium hardness is calculated. Okay, next one we are going to see is nothing but magnesium hardness. Okay, so as I said previously, what do you mean by magnesium hardness? It's nothing but hardness of water is due to presence of magnesium ions. We call the hardness as magnesium hardness. புரிஞ்சுதாமா? So hardness magnesium ion இருந்துச்சுன்னா அந்த hardness நம்ம என்ன சொல்லுவோம்? magnesium hardness சொல்லுவோம். சரியா? இந்த magnesium hardness கண்டுபிடிக்கும்போது நம்ம ஏற்கனவே சொன்னது மாதிரி calcium hardness கண்டுபிடிக்கும்போது என்ன பண்ணோம்? மெக்னீஷியத்தை வந்து ரிமூவ் பண்ணிட்டோம். அதே மாதிரி மெக்னீஷியம் ஹார்ட்னஸ் கண்டுபிடிக்கும்போது கால்சியத்தை வந்து ரிமூவ் பண்ணும். அது எப்படி ரிமூவ் பண்ணுவோன்னா, யூ டேக் தி வாட்டர் சாம்பிள், ட்ரீட் இட் சோடியம் டங்ஸ்டேட். என்ன பண்ணணும்? யூ ட்ரீட் த சாம்பிள் வித் sodium tungstate. Calcium will be precipitated out. Okay, and you filter the thing. After filtering, what you have to do is take the filtrate, you add EBT indicator and titrate against EDTA solution, and the end point is nothing but wine red to steel blue or simply red to blue. And from the end point or titer value, you can calculate the magnesium hardness in water sample. I'll repeat the thing once again. So for magnesium hardness, it's nothing but if magnesium ion is present in water, we call the hardness as magnesium hardness. Okay, what you have for estimation, what you have to do here is you take the water sample where you need to estimate this magnesium hardness. You take the water sample, then you add sodium tungstate. As you add sodium tungstate, calcium will be precipitated out. So the precipitated calcium is removed by filtration. After filtration, you take the filtrate and titrate against EDTA using EBT indicator, and your end point is nothing but color change from red to blue, and from the titer value the amount of magnesium hardness present can be calculated. Is it clear? Now we are going to see chloride content in water. So I think you are clear with the hardness. So what are the hardness we have seen here is, first I have said you what is said to be temporary hardness, then permanent hardness, then total hardness, then calcium hardness followed by magnesium hardness. Okay, now only two things remaining I need to take for you. One is said to be chloride content in water, another one is fluoride content in water. Okay ma. So first we can see chloride content in water. What do you mean by chloride content? So if you take water, water naturally contains chlorine. Okay, it contains chloride in different forms. So all natural water contains invariable amount of chlorides as sodium chloride, calcium chloride, magnesium chloride, etc. Okay, so chloride up to 250 milligram per liter is not harmful to human health. நமக்கு லிட்டருக்கு எவ்வளவு இருக்கலாம்? 250 milligram வரை நம்ம யூஸ் பண்ணிக்கலாம், கன்சியூம் பண்ணிக்கலாம். அதுக்கு மேலே இருந்துச்சுன்னா it is not good for health. Is it okay? So how to calculate the chloride content is the method is called as Mohs method. So water sample where chloride is present, chloride will be in the form of calcium and it will combine with calcium and magnesium ion. It can be titrated against standard silver nitrate using potassium chromate as indicator. So the method, because we are using silver nitrate, the method is called this Mohs method. So you take the water sample which contains chloride ion, and where you have to do the, how you have to do the titration is you titrate against a solution containing silver nitrate and your indicator is potassium chromate. So what happens here is the chloride ion combines with silver nitrate to form silver chloride, and silver chloride will be precipitated. Okay, and this silver chloride will combine with potassium chromate to form silver chromate. A red precipitate of silver chromate will be formed, and from the volume of silver nitrate consumed, the chlorine content in water is calculated. What you have to do here is we are doing the titration, and from the volume of silver nitrate consumed, the chlorine content in water is calculated. The chlorine content in water is calculated. It's clear for you? I'll repeat the method once again, ma. So coming to chlorine content in water, what you have to do here is chlorine is found in water in the form of sodium chloride, calcium chloride, magnesium chloride. Many chlorides are there. Okay, so up to 250 milligram per liter is consumable. It is very good for human health. It should not go beyond the limit. Many problems will arise. Okay, so coming to the determination, what you have to do here is we are doing by titrometric method only, and the method is called as Morse method. And what are the chemicals we are using here is your burette solution is nothing but silver, standard silver nitrate, and your indicator is potassium chromate. So it's a precipitation titration. What happens here is chlorine combines with silver nitrate to form silver chloride precipitate, and silver chloride combines with potassium chromate to give you silver chromate, and from the volume of, and the end point is nothing but it will give a red color. That is, a red precipitate of silver chromate will be formed. So from the volume of silver nitrate consumed, the content of chloride in water can be calculated. Is it clear? I'll go with the next one. Next is nothing but fluoride content in water. Okay, ma. So are you clear with chloride content? Yes? Okay. So now coming to fluoride content in water. Fluoride are present in all natural water. If present up to 1 ppm, it's good for dental health. Fluorine is good up to 1 ppm. If it goes beyond that 1 ppm, it is said to be toxic, and it causes a disease in teeth called as dental fluorosis. You have heard of dental fluorosis. Fluorosis na enna, அது என்ன பண்ண, நம்ம enamel இருக்குல்ல பல்ல, we have enamel. So it will weaken the enamel and it will develop a brown patches on the teeth. பல்லு பார்த்தீங்கன்னா வெள்ளையாக இருக்காது, ஒரு மாதிரி சொர சொரன் ப்ரௌன் கலரில் இருக்கும், பார்த்துருப்பீங்க. அதாவது it's mainly because of fluorine content. If it's found to be in excess, if it comes above 1 ppm, this problem will arise, and the problem is said to be fluorosis. If we go beyond this R district, we can see this, we can notice this problem. Okay, so coming to the determination, what you have to do here is this is determined by spectrophotometric method. சரியாமா, சும்மா கண்டுபிடிக்க முடியாது, கலர் வச்சு தான் நம்ம ஐடென்டிஃபை பண்ணுவோம். Okay, and the method we use here is spectrophotometric method, and we use a spectrophotometer for determination. So color use பண்ணி நம்ம ஐடென்டிஃபை பண்ணுறதுனால we need a dye. So முதல்ல என்ன பண்ணணும்னா dye வந்து ப்ரிப்பேர் பண்ணணும். What you do here is you take zirconium 4, which forms a red color dye with alizarin. Yes, alizarin S கூட zirconium 4 combine பண்ணிங்கன்னா ஒரு red color dye வந்து form ஆகும். சரியா? The intensity of the color will decrease by addition of fluorine ions present in water. எவ்வளோத்துக்கு எவ்வளோ fluorine ion ஜாஸ்தியாக இருக்கோ இந்த ரெட் கலரோட இன்டென்சிட்டி வந்து குறைஞ்சிக்கிட்டே இருக்கும். ஃப்ளூரின் குறைவாக இருந்துச்சுன்னா அந்த கலர் அப்படியே இருக்கும். ஃப்ளூரின் ஜாஸ்தியாக ஆக அந்த டையோட கலர் வந்து டிக்ரீஸ் ஆகிட்டே இருக்கும். Is it okay? So what you have to do here is, in this method, what you have to do here is you take 5 ml of the dye and you add to different sets of 100 ml solution of different fluoride concentration. 5 ml dye எடுத்துக்கோங்க, எடுத்து 100 ml sample of different concentration, வேறு வேறு இடத்துலேருந்து நம்ம சாம்பிள் சூஸ் பண்ணிவிட்டு அப்போ அது வேறு வேறு கான்சன்ட்ரேஷனில் இருக்கும். ஸோ அந்த சாம்பிள் 100 ml எடுத்து என்ன பண்ணுங்கன்னா 5 ml டை ஆட் பண்ணுங்கள். ஆட் பண்ணிவிட்டு என்ன பண்ணுன்னா the color of intensity is measured by using spectrophotometer. எதை யூஸ் பண்ணி மெஷர் பண்ணுவீங்க? Spectrophotometer. I'll repeat. What you have to do here is, initially you take zirconium 4, which forms a red color dye with alizarin. Keep it as if. Okay. What you have to do then is you take 5 ml of the dye. ஒவ்வொரு சாம்பிளுக்கும் 5 ml dye நம்ம ஆட் பண்ணணும். ஒரு 10 சாம்பிள் அல்லது 5 சாம்பிள் எவ்வளோ பண்ண போகிறோமோ அந்த 5 சாம்பிள் 100 ml எடுத்துக்கோங்க. எடுத்துகிட்டு என்ன பண்ணணும்னா எல்லாத்துலேயும் 5 ml dye வந்து ஆட் பண்ணணும். ஆட் பண்ணிவிட்டு the color intensity is measured by using spectrophotometer. The color intensity is measured by spectrophotometer. சரியா? மெஷர் பண்ணிவிட்டு என்ன பண்ணுங்கன்னா you plot a graph between fluoride concentration and intensity of color. intensity of color நம்ம என்ன concentration எடுத்தோம் அதுக்கு plot பண்ணும் you get a straight line, and from the calibration curve we can find the concentration of the fluoride ion can be determined. Is it okay? So this is something about determination of fluoride ion. I'll repeat this fluoride ion once again. So fluoride is present in water in different forms, and mostly if you take fluoride up to 1 ppm it is required. It is good for dental health. பல்லுக்கு ரொம்ப நல்லது. சரியாம்மா? 1 ppm வரை இருக்கலாம். ஓகே, அது வந்து நிறைய டென்டல் ப்ராப்ளம் வராமல் பார்த்துக்கும். எது வரையிலும் 1 ppm கண்டிப்பாக தேவை. பட் அதை தாண்டும் போது we get problem. If it comes above that, it causes a disease to be fluorosis. Fluorosis is nothing but it weakens the teeth enamel and develops brown patches on the teeth. அதான் என்னது? ஃப்ளூரோசிஸ், டென்டல் ஃப்ளூரோசிஸ். பல்லு பார்த்தீங்கன்னா ஆட்லெலாம் பார்த்துருப்போம். டூ இப்போல்லாம் போடுறதில்ல. பழைய காலத்தில் நமக்கு வந்து இஃப் யூ டேக் திஸ் பேஸ்ட் அண்ட் tooth powder, for ads they'll show the teeth will be in brown patches. As they use the paste tooth powder, the color changes to white. They show normally, but actual thing is it's mainly because of fluorosis. If the water contains excess fluorine, என்ன நடக்கும்னா fluoride waterல excess இருந்துச்சுன்னா நம்ம அந்த வாட்டரை கன்சியூம் பண்ணிட்டே இருக்கோம்னா நம்மளோட பல்லு பூரா என்ன கலரில் ஆகிடும்னா ப்ரௌன் கலரில் பேச்சஸாக இருக்கும். Is it okay? So this is something about fluoride content, and how to estimate this fluoride content is you have to prepare a dye. Red color dye is being prepared. It's nothing but zirconium 4 with alizarin. Yes, it becomes a red color dye, and the nature of this dye is what happens there is if you add this dye to water containing fluoride ions, what happens there is the intensity of the color will be decreasing. The intensity of the color will be decreasing. புரிஞ்சா என்ன சொல்கிறேன்னு? உனக்கு ஃப்ளூரின் இருக்க சாம்பிளில் இந்த ரெட் கலர் டார்க் ரெட் கலர் டையை நம்ம ஆட் பண்ணோன்னா உனக்கு ஃப்ளூரின் இருக்குன்னு வச்சுக்கோங்க, அந்த கலர் வந்து குறையும், டல் ரெட்டாக மாறிட்டே இருக்கும். ஃப்ளூரின் கண்டென்ட் குறைவாக இருந்துச்சுன்னா அதே கலரில் இருக்கும். ஃப்ளூரின் கண்டென்ட் ஜாஸ்தியாக இருந்துச்சுன்னா அந்த ரெட் கலர் டிமினிஷ் ஆகி கலர் வந்து கொஞ்சம் ஆரஞ்சிஷ் ஆகிட்டே இருக்கும். Is it clear with the point? So this appearance ரொம்ப பார்க்க முடியாது. So we use a things to be spectrophotometer. அந்த apparatus வச்சு நம்ம மெஷர் பண்ணலாம். ஓகே, ஸோ நீங்கள் என்ன பண்ணணுன்னா ஒரு 5 சாம்பிள்ஸ் எடுத்துக்கணும். எடுத்துகிட்டு என்ன பண்ணணும், டிஃப்ரெண்ட் கான்சன்ட்ரேஷனில் எடுத்துக்கணும். ஒன்றுக்கு 5.05, ஒன்றுக்கு 0.5, ஒன்றுக்கு 1, ஒன்றுக்கு 2, அப்படி டிஃப்ரெண்ட் நார்மாலிட்டியில் we have to take different concentration. You take 5 or 10 samples, then what you have to do is you add 5 ml of this dye to all the samples, and you note the intensity of the color by spectrophotometer. After noting, what you have to do is you plot a graph between fluoride concentration and intensity of the கலர். அந்த ஸ்பெக்ட்ரோஃபோட்டோமீட்டர் வந்து டிஜிட்டல் தான், உனக்கு ரீடிங் வந்து டிஸ்பிளே ஆகும். சரியாம்மா? அதை வச்சு நம்ம பிளாட் பண்ணணும். ஸோ ஆஸ் யூ ட்ரா த கிராஃப் ஃப்ரம் த calibration curve, what you can do is you can find the concentration of fluoride ion present in the water sample. Is it clear for all of you? Yes? So we can have a short recap of the thing what we have seen for today's class. So first thing what I have taken for today's class is hardness of water. There are temporary hardness, permanent hardness, then we have seen what is total hardness, followed by calcium hardness and magnesium hardness, and finally I have taught you what is said to be chloride content and what is said to be fluoride content in water, and how to estimate this chloride content in water, also how to estimate fluoride content in water. Chloride content is determined by Morse method. It's nothing but by using silver nitrate and potassium chromate indicator. Coming to fluoride content, what you have done here is we have prepared a dye with the zirconium 4 and alizarin S, and we have measured using a spectrophotometer. By drawing the calibration curve, you can find the concentration of fluoride. Is it clear for all of you? Yes. Thank you for listening. Keep on studying. Thank you, ma.